But then this IDL would have to import the helper IDL. And that works. You just say down here, just at line 36.5, you'd say import, and you'd list the IDL file. You give a hard path to the IDL. The problem is that the IDL compiler isn't quite smart enough. It creates, one of the things it's creating is a header file, iuser underscore i.h, and that pounds include the wrong thing. Okay, it's the wrong address. It's a bug in the MIDL compiler, and it's easy enough to fix. You just go in and by hand, you can just change. You look at the file. You get the compile error. It says like, I can't find this pound include file. You go, you can fix it. Piece of cake. The only problem is every time you rebuild it, you got to go back and refix it, because that underscore i.h file is a generated file. So it won't keep your fix. So instead, what I did was I'm passing the pointer as an unknown pointer, and this guy doesn't need to pound include helper IDL because it's unknown, and he already knows what unknown is. Okay? So he's perfectly happy doing that. So I send him the pointer, and I get the result. Now, the using.h, there isn't much here except that if you go down to the bottom at line 58, you can see he's caching, he's holding on to that p helper pointer as an unknown pointer. Okay. So I'm going to send him the pointer, and then later on, in the next function, he's going to use it. Okay. So now, let's look at the using.cpp. So at line 13, here's the send helper method, typed as unknown, and he just sets phelper unc to phelper if. So this is the pointer. That pointer is bound to that, that object, but it's typed as unknown. So, and as this assignment works fine. Everything's great. Now, at get result, he needs to use it. So now it really has to be an iHelper pointer. So line 27, I declare a ccom qi pointer iHelper, phelper, and I just assign it the unknown, and that works. This ccom qi pointer is smart enough, and its assignment, if it gets an unknown, it queries, it knows it's got a template argument for the type, and so he just does a query interface on that template argument on the pointer that was assigned to him, and it works. Okay. So we're getting the equivalent of polymorphic behavior by doing that. POM really isn't polymorphic, but we can simulate that little bit of work. And so then he just uses it, phelper get result. He gets result, and test it. Notice at line 37, he's going to return this result to the client. Here's the result with is his part, and now he's got the helper result from that he got. At line 31 and 32. So ccom beasters are smart enough to do plus equals. And they're perfectly happy to take a non-beaster, if that was a beaster, or a beaster, either one. But so that works. And then when you return it, remember that the client is passing in a pointer to the place where he wants you to store that beaster, because it's an output parameter, he has to. And so at line 40, we're writing that result into where that pointer points to. Okay, and then you got to detach him so that when he goes out of scope, he doesn't deallocate while the stub is still trying to send stuff over. I don't think it would be a problem here because we're in the same apartment. But if we're in two different apartments, and the stub is trying to send stuff. So you need that detached. And then helper comp.idl is really straightforward, nothing much going on there. Just, there's a put string and a get result function at lines 30 and 31, and they're all just beaster type stuff, no problem. If you turn to helper.h, the only thing I want to bring to your attention is that at line 56, he's holding on to the beaster. Okay. He's got a, that's the place where he's going to store the path from the helper. It just stores it. And the comp part of that is straightforward. Okay, so that's the helper. It's the structure you need. This structure satisfies the requirements for project one. And now, your job, your mission is to fill in the guts. Okay, Ayu. Thank you for your patience.
Hello everyone, I'm Hao Yuan, presenter today. Today I'm going to give you the first presentation of my final project, a cross-platform Markdown application based on Electron Framework. But before we dive into the detail of the application, I want to give you guys a brief introduction about Markdown. Markdown is a lightweight markup language with plain text formatting syntax, which looks exactly like the content in the first column here. What's magic about Markdown is that it can be converted into HTML and many other formats. So for me, it's a very simple and convenient alternative to write something like a to-do list, a README file, or even a blog. By mastering this extremely simple syntax, basically everyone can write something beautiful and well organized without opening a giant tool like Office Word. Now let me tell you why I want to build this application in the first place. There are many great Markdown applications on the market already, and all of them have beautiful user interface and some interesting and handy features. The first one I want to introduce is Easeljs. This application provides user with the ability to publish their Markdown file to the blog platforms like Medium or WordPress. Another interesting feature about this application is inside of it, there is an elegant file management system that helps users to handle the editing file easily. Another application named Bear, and this application offers user with ability to export the Markdown file to various file formats such as HTML, PDF, or even docs. And those applications are really great, but there is a common problem for both of them. That is supporting platform. They can only support Mac. And users from Windows and Linux, they really need some good quality Markdown applications. And when I think about that, the idea of my applications appears. So I want to merge the interesting feature of those applications and build a cross-platform Markdown application that has those following features. The first one, adapting to Windows, Mac, and Linux. This is the most interesting part of my project, because we all know that developing a cross-platform desktop application can be full of challenge, and make it really hard to approach. Not only because of untangling a set of specialized tool, or you have to maybe mastering a whole new programming language. But also, as a developer, you need to translate your design into different format, into different operating system. And I mean, that's just the beginning of the painful path you want to follow. Now with the Electron Framework, those challenges can bother developers no more and allow us to purely focus on implementing the functions of the application, which in my case are the following features. So publishing to blog platforms, including Medium, WordPress, and GitHub pages. And next one, uploading image to image host platform. The application itself will support both Google Photos and Imgur. For this feature, I want to explain a little bit about its motivation. Suppose you have this Markdown file that contains a lot of images. No matter where you save it, and maybe locally, or you use the second feature to upload to some blog platform, or you save it on the cloud server like Google Drives or iCloud, this file will cost a lot of space. And we all know that after when you run out of the free given space, the extra space you're gonna pay for those extra space. So this feature is here for you to solve this problem. Basically, it allows users to upload these local image to the image host platform and get the URLs back. Then the user can replace those local image with a URL. By doing that, the size of the file will shrink dramatically and problem solved. And both those image host platform will provide user with unlimited storage space.
So you're probably affecting the latency of your application, I would assume.
Actually, this feature is done by a synchronized technology. So you will send a request, upload the image and wait for the, and you can do something else and waiting for the result comes back. Because those URL links will be saved into the clipboard. So when it's done, I will show you like a alert window. Something the URL is ready, so you can just paste it on the editor or somewhere else you want to use.
That's for when you're doing your application, but you're proposing hosting those images, not hosting the Markdown, but hosting the images on an image server.
Yeah.
Right, like Flickr or whatever.
Yeah, just Google Photos and Image.
Yeah. Okay.
Yeah.
So now when somebody's looking at your application, they download your blog. They open your blog.
Yeah.
To see the images, they got to come down from Google.
It's just a super link. So you open the file. If you have the internet connected, you immediately see that.
Doesn't mean you won't get them, but there is a latency. You don't get if the image is
Yes. I know what you're meaning, but this feature is to save the space. It's to save the storage space.
Okay. I'm not complaining at you. I'm wondering.
Yeah.
The effect what will the effect be on you? Okay.
Yeah.
It's an interesting idea.
Hopefully. Next, exporting to multiple formats, including PDF, HTML, PNG, and docs, and different application layouts, multiple languages, and themes. Next, let's take a look at the structure of the application. As you can see, the structure of the application is quite simple and straightforward. There are two major components that makes up this application, the Electron Framework and Node.js helper module. The Electron Framework here is responsible for talking to different operating systems like Windows, Mac, or Linux. And it gives developer the ability to use native features like notifications or menus. And Node.js helper module here it can take care of the implementations of those features. So you can and when you combine those together, that's the very basic structure of this application. Hope you guys get that. Now let's see a very simple example about the Node.js helper module part. Here, I want to implement the blog publishing function, and I will let the application use the Node.js HTTP module to send some get or post request to the blog server and to do the publishing operation. And then at the same time, I will let the Express package listen to some specific part at a specific port at the local server to get the information sent back by the blog server. And now let's talk about Electron. First, what's Electron Framework? Electron is an open source library that was created by GitHub back in 2013. And it is used to create cross-platform desktop application with only HTML, CSS, and JavaScript, which is awesome because those languages are universal and with a huge supporting community, which means that you can there will be tons of frameworks, packages, or libraries for you to take advantage of. And it does that by combining Chrome web browsers and Node.js into a single runtime. If you don't know what Chrome web browser is, it's just a open source web browser that Google Chrome draws its source code from. So basically, it's very similar to Google Chrome, but there are some difference in the features and the licensing is different. With this powerful web browser embedded in the, packaged in the framework, developers don't need to worry about crafting conditional rules for dozens of different browser versions. And also, they can code with confidence, knowing that everyone using the application runs it under the same set of conditions. And the most important part, the applications can be packaged for Windows, Mac, and Linux. Before I talk about the theory behind the Electron, let's see some interesting apps that are built on Electron. The two most famous ones for me are VS Code here and Atom here. And I believe a lot of us use VS Code for the first project of this course. And if you go to the web link here, you will see a full list of the applications that are built on Electron. Now, let me try to explain how Electron works behind the scene as best as I can. Basically, there is a main process and there is a renderer process. The main process runs the package.json's main script, which is usually called main.js, but you guys can call it whatever you want. And it can display the graphic user interface by creating web pages. The main process creates something called a browser window, and this browser window runs a web page in its own renderer process. When the browser window is closed or destroyed, so is that renderer process. And the main process itself manages all the web pages, browser windows, and the renderer process. Sorry, I chose the wrong color. So the diagram here shows one application has only one main process, and then it can branches off to several renderer processes. And that's the basic idea about the Electron framework. Hopefully you will get the idea. And when I show you guys the demo code in a minute, that might shine some light on this as well. First, let's take a look at the package.json. As you can see at the independent section, the Electron framework has already been added into the application. And here at line 5, we see the entrance of the application also is the main process that I mentioned before, is the main.js. So let's take a look at the content in the main.js. Inside of this file, we first load some needed module from both Electron and Node.js, and then let the Electron framework to decide whether the application is ready or not. So when the framework says, okay, the application is ready to go, the first job is to create a browser window instance, and which is also the renderer process. And then we will have the browser window instance to load the URL. Here, I just load a local file URL called hello-world-demo.html. When you build your own project, you can load whatever URL you want. And if everything works successfully, this browser window we just create will render the content of this Hello World demo.html. Let's take a quick look at the content of that. So it's quite simple. Basically, nothing inside of the body section, and there is only a text title says Hello World demo. Let's see how it looks like. It works out. A blank window with a title says Hello World demo. And you may concern, is this really a mini browser? And is this a web page we just render to it? Let me show you something. Our old friend, familiar developer tool, and the source code is right here. Now you're confident this is just a kind of like mini browser. Also, I should mention that I didn't do any extra setting, and already the Electron Framework offers us with the native feature menu bar at the top here.
The code looks very Nodejs. So if you look at that, can you put the window down? And so that code looks very Nodejs.
This one?
Yeah. So so Electron is sitting on top of Node.
Yeah. Yes.
Yeah, okay.
Yes.
It can't run independently. It has to have Node as
Yes,
part of it. Yeah.
yes.
Okay. Good.
As I said before, it combines the Chromi and
Yeah. It's a
Nodejs.
package. Yeah. But basically it's a Node package.
Yes.
Yeah.
Let's continue. Without doing anything, the framework itself already provides us with the native feature like the menu bar. And let me show you how easy it is to code something. Just hello. Save it and back to the window and reload it. You see the result instantly. That's how easy it is to use this framework to build a cross-platform application. And remember, no matter which platform you choose, the layout inside of the web browser will be the same. Now the demo. Last one, schedule.
I just had one question.
Yeah, sure.
How do you make it dynamic? Make the window dynamic? Want to make changes to code?
Dynamic? That's kind of technology detail, but I will show you.
I assume you just used Ajax, right?
No, actually, I'm using JavaScript, pure JavaScript to make it. I mean, are you asking the different layout?
No, what I mean is if you want to make any changes to data in the page window itself.
Oh, yeah, just pure JavaScript. So
you have some backend JavaScript functions.
yeah, sure.
You run the script and it will do the script.
Yes, yes.
But that's really what you're going to use your Markdown for, isn't it?
Yeah.
The Markdown will be a layer between Electron and
Node.js.
Yeah.
And schedule. By the time of by the 14th of March, I will finish building the overall web page layout. I mean, using HTML, CSS, and JavaScript. And 17th of March, the basic editor function and preview function will be supported will be embedded into the application. Next, 23rd of March, I will finish implementing file management system. And
it's not clear to me from what you've discussed so far why you need a file management system. Do you have some ulterior motive that you're going to use the system for that you haven't told us about yet?
No, actually, I want to list this in the future, but I forgot to add it. And this one, never mind. by 26th of March, I will finish implementing exporting formats, and those four, I think those four formats will all be supported and by then. And at 4th of April, the application will be able to upload the image to the image host platform, and then I will spend 15 days to implement the blog publishing function. And all the arrangement of all the time that left, I will do I will fix all the bugs and do some overall enhancement. That's it. Do you guys have any question?
I've tried Markdown once and I didn't get, but from what your description, I think you want to turn Markdown into an application. Is that?
Yeah.
So it's for a blog post?
That's kind of like a feature, just an extra feature for the Markdown. The application itself, the basic application has the ability to write Markdown and live preview it.
I thought the starting point is a Markdown and end point is application. So you're saying Markdown is sit in the middle?
No, you're right. Markdown is at the beginning, and then I add each feature on top of it.
So what the end application would be like? It's just like any other application, or it's like a web page?
No, it's a pure desktop application.
But your desktop application, for example, could publish a blog. What you're saying?
I will publish
with the help of Markdown.
I mean, those Markdown files are most frequently used in the blog platform, like Medium or WordPress. So with the, communicate with the REST API of those platforms, I can upload the local Markdown file to those blog platforms. That's a feature.
Okay, so your application really is, you're an editor for various different applications, and then you're going to upload that edited stuff for them to run. Is that right?
Yeah.
Okay, cool.
For me, I use Markdown a lot, and for me, if an editor is just an editor, I mean, if a Markdown editor just have the ability to write it, that's not a complete software. So the whole circle should be, write it and publish it to somewhere for people to view, and that's the whole process.
Question.
Yeah.
Will your application will support those like real-time rendering? Because if it's a pure Markdown syntax for the beginners, it may be very hard to understand. If you can add those renders, those HTML, it will be, I think it will be fancy.
Yeah, here, the basic editor function and the preview function. Because I view those two functions as the very basic function of a Markdown editor, so I didn't put it in the feature slide. Okay, here's the plan. I've already figured out how to do this one, and the following one, I think, I've already figured out the PDF one and HTML one. The PDF one is fairly simple. Because here, I have a preview function, right? So it should be, let's say, some section, some window that's part of my application, right? And Electron very sweetly provides us a function to print out that browser window, the content inside of that browser window.
So how do you do the?
How do I do the preview? So when I have the file out of the editor, I will have a parser. I will have a parser component, which is a helper module from Nodejs to parse that file immediately and show the result at some part of the application, which is as some part of the application. And if you want to print it out, I will I will create an invisible browser window and let the Electron print out the content in that invisible browser window, and then you get the file.
Yeah, I got it. But how do you, if you want to display it in preview window, an invisible window?
I think they're just gonna, because their Markdown is very primitive, expressive. So you turn it into HTML and you just use the browser.
That's what I'm saying. I think you need to like convert it into HTML.
Yeah, I said the parser module from Nodejs will help me to do that.
So do you write the plus Nodejs?
Nodejs has this module for me to use. So I don't need to worry about how to convert it. I just take the file out of the editor and convert it right into the HTML and render it in the browser window. Any question? And that's my presentation.
So just a quick question.
Yeah.
Markdown was developed by GitHub or Pages, I think. Is that true? Do you know?
I really don't know.
I know GitHub Pages uses Markdown.
Yes.
From their docs, they appeared to say that they were the authors of Markdown. Maybe they're not.
I mean, this is really a handy tool to use, but
Yeah.
I don't care, who invented
I mean,
it.
the big thing about Markdown, correct me if I'm wrong, but it seems to me the big thing about Markdown is there's a common way of expressing stuff, and then a lot of key-in transformers that put it out into these different formats,
Yes,
right?
yes.
Because for me, I look at it, that's harder than writing HTML, okay? but the fact that you can go out to all these different, that's cool.
Yeah.
Good. Thank you. Again, presenters, when you're try to put an end. So, oh, you do have an end slide. I'm sorry, you just didn't get to it. Glad you picked this topic. This is a subject near and dear to my heart.
Great. So hello everyone. My name is Arash. The project I picked is graph visualization, and I decided to do it in TypeScript because I liked it. So here's the idea behind the project. There is like this issue of visualizing big graphs, like, for example, graphs of dependency in software components dependency graphs. And the issue is it's hard to come up with a nice algorithm that can figure out the optimal layout for such large graphs with lots of nodes and lots of edges. So one, I think, interesting idea to solve this is to treat these graphs as like physical objects with forces between them and so on. And what I mean by that is, we have these nodes, and we can put forces between them. We can say nodes have repulsive forces between them, so they repulse each other. And the repulsive force can be proportional to the inverse of the square of the distance, which is like in Newtonian physics. And these edges can keep the nodes together. They can force the nodes to be at a fixed distance from each other, the nodes that have edges between them, or they can be elastic. Like if two nodes with an edge between them get too close together, the edge can push them apart, and if they get too far away from each other, the edge can like bring them back together.
Why would you change the direction of the force on the edge? I mean, you already have a repulsive force between the nodes. I would think just a one-way force on the edge would be all you would need.
And what force on the edge?
Why would the edge ever push nodes away? Because the nodes already push themselves away.
The edge is supposed to keep the nodes together. But my idea is it can either keep them at a fixed distance, or I can say, okay, if the nodes get too far apart from each other, the edge brings them back together, or there is like an attractive force between them. And if they get too close to each other, the edge can repulse them. That's like an idea that I thought of. Or I can like force them to be at a fixed distance from each other.
So it's like a spring.
Yeah.
I just don't. I see no reason to have the edges repulse because you already have a repulsive force between the nodes. The 1 over d squared.
Yeah, that's correct. That's an idea. I mean, I can not go.
I'm just, I'm not telling you to change anything. I'm just.
But like the analogy of the string is a good one, I think. So if you squeeze the string too much, it exerts a repulsive force. If you open it too much, it wants to contract. Anyway, so this allows. So I have this physical system with these forces, and what happens is that the forces force the graph to rearrange itself organically. And so if I have a graph like this that's like all jumbled up, hopefully the forces would, turn it into something that's easier to make sense of. And
probably would want a damping force as well.
Absolutely, yeah.
Okay.
I don't want to get into too much detail,
sure.
But yeah. So if there are nodes and they are not connected to any edges, they don't go away forever. And also the idea is that the user should be able to move these nodes by hand. So the graph is rearranging itself, or it's already rearranged itself, and the user may not be happy with the layout, so he can drag this node somewhere else, and it forces the graph to rearrange itself again. Okay. So the technologies that I want to use in this project are first, or mostly web technologies. So I'm going to use HTML and CSS, and for drawing the graph, drawing the nodes and so on, I'm going to use HTML Canvas, which lets me draw stuff in a web browser. And I found this nice little library called Easeljs. That's a graphics library that sits on top of HTML Canvas. So the difficulty with HTML Canvas is that you have to issue primitive drawing commands, like move to this point and draw a line, and then move to the other point and maybe draw a circle and so on. But with this library, I can define shapes. I can say, okay, I want a circle here, a square there, and later on I can say, all right, move that circle over there and the square over here, and so on and so forth. And then I'm going to use TypeScript, which I'll get into. And finally, Electron shell to package my component as an application, as a demo application. So I guess you're already familiar with Electron shell, so I won't spend too much time on it.
It's not clear to me the role that TypeScript is going to play.
I'll get into that, but
Okay.
since
I'll wait
I'm
if
using web technologies, I have to use JavaScript, and TypeScript is an alternative to JavaScript. Okay, I guess I talked about Easeljs. The features that I care about in Easeljs is that it has, like I said, persistent objects, so I can define my objects and I can move them around and change their properties and change their colors and so on and so forth. And also it has a nice mouse interaction model, so when I click on a circle over here that's been drawn by Easeljs, it can give me an event that I can figure out what to do with.
So these objects are really TypeScript objects. That's the only thing that TypeScript really gives you, right? Is the little super syntax and object, the ability to.
The Easeljs objects are like, no, they're just JavaScript objects. Easeljs is a pure
Yeah,
JavaScript.
but TypeScript lays a type system on top of that.
Yes, absolutely.
Okay.
Okay, TypeScript. So I'm going to use TypeScript, like I said, mostly because I like it, but the point of TypeScript is to make writing big JavaScript software manageable. I have it here that it brings sanity to JavaScript, and by that I mean static typing. So it's said that JavaScript was designed to write applications that maybe are 100 lines of code or so on. But today, because it's like the language of the web and there's Nodejs, people are writing entire applications that are like hundreds of thousands of lines of code instead of hundreds. But it's hard to do it in JavaScript because there's no type system in JavaScript. So what TypeScript adds to JavaScript is this static type system. I say here that it lets you express your intent when you're writing code. So when you're writing, for example, a function in TypeScript, you can say this function takes these parameters, and these parameters have these types and returns this type. If you're writing the same function in JavaScript, you can't say that. And later on, when you go back to your code, it's hard to make sense of the code that you wrote. And now, because these typing info is available, TypeScript can help you when you're writing your code. It can catch your errors, catch your silly mistakes, like mistyping a function name or something like that, or passing 2 parameters to a function that takes 3 parameters.
When you're using Atom or Visual Studio or VS Code, you get IntelliSense from the TypeScript?
Yep. Good. I'm going to demo it. And in the end, TypeScript compiles back to plain JavaScript. So it runs on any browser, it runs on Node, there's no problem there. So here's a simple example of a 4-line JavaScript code that's supposed to remove an element from an array. And can anybody tell me what's wrong with this piece of code? What? No, the condition is correct. Okay, so this kind of shows what the difficulty of writing code in JavaScript. I'm going to switch to this code, please. Here's the same function. and try and run it. Okay, node demo1.js. And it gives this cryptic error that 42 is not a function. Now if I were to just rename the same file to, yeah, if I were to rename the same JavaScript file that I have TypeScript, let's see what happens. It's complaining. It's saying that this guy has type any. So let's give this guy a type. Since I want it to be an array, I say needs to be an array of numbers, and element needs to be a number. And let's see what happens now. It's complaining about the thing that I passed to. It says argument of type number is not assignable to this function. So I guess find index takes a function. So let's see what I should have done. But this is the interesting. This TypeScript now knows what the type of R is. It knows what functions are available, what methods are available. And what I should have done was to use index stuff. And now it's not complete. Now, just to show you that it works, I need to start the TypeScript compiler very quickly. And it just sits and converts all the TypeScript files into equivalent JavaScript. Let's try this again. And it works fine. So I hope it showed like the value that TypeScript brings. And this is the code I intended to write. TypeScript helped me fix it. But TypeScript has like lots of interesting features. As a structural type system, so you do not need to. The objects you have do not need to have specified what type they are. They just need to match the shape of the type that you want to use them as. It supports generics, so like my previous example, I can have this function, pick an array of anything. And if I pass it an array of numbers and try to remove a string from it, it will complain. It supports non-nullability and lots of other interesting features. So just let me quickly demo some of them. So here I'm just defining an interface, and I'm defining another interface. And I can combine these two interfaces by saying my user interface extends both those interfaces. And here's a little function that's supposed to take a user and save it. I define an object that's just JavaScript, a plain JavaScript object. And when I try to save it, TypeScript is happy because the shape of my object matches what a user expects. That, the right properties of the right types. But if now I have this other object that doesn't have the right check. Now, if I try to save this guy, TypeScript complaint says the types don't match and so on. Okay, here's another interesting feature. We can have intersection types. So I could have written my save user function instead of defining an user interface. I could say this person parameter must be of type person and in entity both. And again, I can pass my object to it and it's happy. And again, if I have something that whose type doesn't match, TypeScript complaint. Here's another interesting feature. We have union types as well. Now I'm saying person needs to be of either type user or type string. So my save user tree function accepts either of those, but if I try to pass something else, it complains. And I'm passing something of type user here, and I'm passing a string here, and it's happy with both. So that if I pass something of the wrong type, it figures it out and
is that equivalent to an overload, semantically equivalent to an overload?
it's kind of like an overload, but in JavaScript.
Yeah.
Because the authors of TypeScript, they try to come up with a type system that matches the patterns that people use when writing JavaScript. And one of the patterns that they use is they take a parameter and it can be of various shapes. And this union type can help support that. Okay, this is like a small example of, again, using the type system. I'm updating my function with this new value. I'm updating my object with this new value. I just want to change the SSN field in it. And again, since it's strongly typed, if I try to set SSN to a string, it figures it out and complains. And these structural typing, union types, intersection types, these are features that are not available even in other statically typed languages. Like you cannot write an equivalent function in C# that does the same thing, or in C++ or in Java. So here's an example of promises. Or what I'm trying to show here is the support for generics in type system and how types can flow. Would be bored if I try to get into details, but I can make another point that when I first wrote this little piece of code, my intention was to, if here the result is true, I should pass another request to the server, and if the result is false, it means our hash is already deactivated, so I don't need to do anything. So I didn't put an else clause in there. It was something like this. But it means the type was wrong. And if I was writing the same code in JavaScript, it wouldn't complain and it would blow up in my face when I was running my code. But the type system helped me hash the code, hash the and these are again examples of the type system and the type system features. There's this key of keyboard in type system that takes a type and returns a type whose values are the keys of the type that was passed to it. So what we can do with it is we can like write something like write a function like this. I'm saying I want to copy properties from this first object to the second object. And if a property doesn't exist in them, I would like to know about it. And I'm writing my code. So if I try to copy the property blah, it doesn't exist and TypeScript can. And my last demo is of tuples in TypeScript. Again, this is a pattern that people use when writing JavaScript code. They use JavaScript arrays as tuples. And TypeScript supports that. So this me tuple object here is of type a tuple of string and number and number. So when I try to access the first element, TypeScript knows that it's of type string, so my item 0 is of type string, and my item 1 is of type number. All right. So these are some of the interesting features of TypeScript. So writing code in TypeScript is nice and good, but most of the libraries out there have not been written in TypeScript. And if you want to use them in TypeScript, you want to have, you want to know about their types, like know about the types that you write yourself in TypeScript. So what's the solution? The solution is these typing files with the extension .d.ts. These files, they don't contain any code. They are just they just describe the types and the shapes of libraries, of APIs. They're kind of like header files.
Language schema.
Yes, yeah, kind of, yeah. And there's this repository called definitely typed that collects these .d.ts files for popular JavaScript libraries. There's over 3,000 of these type definitions in them, or 3,000 of these typing files for over 3,000 JavaScript libraries. And using them is very easy. All you have to do when you want to use a JavaScript library, all you have to do is write this command and pass the name of the library here. And it goes to this repository and grabs the typing file. I'm also going to use the Electron Framework, but the last presenter told you all about it, so I won't spend too much time on it. Again, these are the things that the last presenter talked about. It lets you create desktop apps. It gives you access to the file system, to network through sockets, and so on. It provides things like crash reporting and automatic updates also. Instead, what I can do is, just again show you how TypeScript can help write Electron apps. So here I have an Electron app, and I'm trying to access the file system. Since I'm in TypeScript, my fs library is strongly typed. I type fs dot, and I see all the functions that this library provides. I can say, okay, I want to create some directory. I don't want to deal with async stuff, so I I'll hit dear sync, and let's see what parameters it takes. Okay, it takes the path. I pass it the path. From this pop, I see that the second parameter is optional, so I ignore it. And now I have access to the contents of my C drive. And I can see what the type of this whole thing is. I have it right here. This is the string guide. If I want to display the contents of my C drive, I can, since this is an array, I know, or I don't know. TypeScript tells me that there is a reduce function on it that's kind of like fold or aggregate, so I can do a little bit of functional programming with the help of TypeScript. So it tells me the type of the parameter that I have to pass to it, and what it has to return, and so on. And what I'm doing here, I just concatenating the elements of this. And what it is supposed to do, as you have guessed, is to display the contents of my C drive in my Electron. If I try to run it, here's the contents of my C drive in my code shows that I can access these native features, native resources like the file system and so on from Electron. And again, that TypeScript makes life easier. Okay. So these were the technologies that I'm planning on using, and this is my timeline. I'm going to use this Easeljs library and write a component that can draw graphs by end of this month or close to the end of this month. And the next phase would be to adding physics simulation and mouse interaction to this to my code. I'm planning on finishing that by mid to late April, and then I'll package my code in the Electron shell and probably add like a couple of features like loading graph files and so on by the end of April. And if things go well, I've been thinking of, I have this physics simulation code that's supposed to drive the graph layout. I was thinking of maybe turning that into a kind of a physics engine for games and create a simple game on it. That's it. So that was my presentation.
Interesting to be able to annotate the visualization. So you could use it as because there's a lot of tooling behind that. You could draw, static structure of a body of software, for example, draw the graph, and then as you learn parts of it, annotate the graph to capture your current knowledge of the system. That'd be really useful. Well, for example, Dr. Drew's research guys have to learn the Linux kernel. It's not such an easy thing, but if you have a static parsing tool, that'll draw graphs, like call graphs and stuff like that, and then you can kind of annotate as you learn what's going on. That would be really interesting and useful.
Yeah, that's a good idea. Like add metadata to the graph.
Good, thank you. I don't think it's time for the third presentation, so you guys will be the first up right after spring break. Okay.
By the way, no question?
It seems to me that if you want to add mouse interaction, it's best if you do a little physics, more like a particle engine first, then put the physics engine in the visual scope. Because if you if you do it manually, then it might become a problem for the simulation itself.
My physics engine, it's not supposed to be something. Just
exactly.
A bunch of objects,
that's why
there are forces between them and so on.
Yeah, that's why if you want to do the simulation, you might want to do like a slice of a particle physics before the other stuff, the rendering. That's more sensible to me.
I guess I'm planning on having the rendering code separate from the physics simulation.
Yeah, but I saw the physics engine is in the ambitious code. Running.
No, my point is that turn it into like a full-fledged physics engine.
Okay.
Independent of graph drawing stuff.
Okay, presenters, would you upload, please? All the ones I have so far are, I think everybody except today's presenters have now uploaded, and they should be available on the website. I think they're all there. If you go to final projects, I think the folder is, and there's a tech presentation. You'll find that. Everybody's. Thank you all for presenting, and we'll see you all. Have a good spring break. We'll see you after the spring break.
Thank you.
I have one
Just have to contact.
criticism of what you did. In your presentation, you were talking so low. It was very hard for me to understand part of your conversation. Okay, so if you could project out a little more, get a little louder. That would be a big help.
I'm not sure yet.
Okay.
Yeah. I'll have to wait until she gets back.
Sure.
I know. Want to promise anything,
I'll show you.
but I just don't know.
So you'll be letting us know within.
I'm hoping that she gets back today or tomorrow.
Do you know her name or something?
Yeah, Xiao.
Cal?
Xiao. I don't know her
I
last
don't
name.
know her.
She's a computer science.
I haven't heard it.
What's her last name? Xiao is Dong.
No, I'm not. Probably she'll get back to you today because yesterday we had many.
Yeah.
Today people have.
Yeah, exactly. So.
Okay.
I'll just
You're gonna join?
maybe. I'm in another group, but I don't like the last I heard.
Okay,
Was like
so
we had 9 or 10
If you just
people
go
or
to,
something.
In that group, 9 or 10?
Yeah, and so if it's that, then I'll just say. But we haven't talked or anything. Like I literally like saw the people one time and like
Okay.
I don't remember.
No problem. Let us take 2 minutes. Okay.
Yeah. Okay. Have a
Okay,
good
bye.
night.
You too.
just go to the website, my website,
So,
and
I was thinking about what I was thinking.
so projects.
With
Upload projects. Upload projects. And you'll see a CSE 775, and that'll give you, you put in your credentials and we'll upload it. Okay. Yep. Uh-huh.
We should have a family.
Yeah, I've forgotten. Let's go to my office and we'll chat for a minute. I gotta remember the issue I had with yours. I've forgotten now. Do you have the slides with you? A hard copy of the slides by any chance? Okay, yeah. So why don't you, we'll talk about it in my office. I can't, because I have to be fairly quick because I got some place I gotta go, but. And I'll chat with you quickly too if you wanted to chat with me.
No, I just want to ask you, like, if I have to send you a reminder email.
About changing the schedule. Why don't you do it again? You know, you sent it yesterday, right?
Yes.
Yeah, no, you don't need to send it over.
Have a good break.
See ya.
Hi, Professor.
See ya. I liked your presentation. You did a good job.
Really?
Yeah. Yeah. You
Really?
sound surprised.
Yeah.嗯，然后在这儿做也行，但是也得等一会儿，小伙伴得5点到5点半。好累呀。
我去隔壁办公室，来个点事。
行，那我在这儿等。